Why should you ever use boiled water to clear ice or to get rid of any existing ice? Well, besides the obvious logical leap of hot beating cold, the Mpemba effect is a thing too. While I don't think this is a commonly known phenomenon, it is one we could stand to learn just a bit more about. The Mpemba effect is basically scientists gathering together to observe that hot water freezes decently faster than cold water does. Why would this happen? Well, there's actually a lot of debate on that little topic alone. There are lots of theories that suggest that if you start with hot water, you get some benefits that you otherwise would never get with cold water. For example, hot water evaporates a lot faster than cold water, and that means less overall water has to freeze. Then, you also get convection currents that help cool the water since the cold travels a lot easier. Plus, hot water doesn't supercool, and supercooling is essentially just a state where water's temperature goes below the freezing point, but it doesn't turn to ice. Since hot water doesn't run into this issue, it actually might be possible that this helps it freeze a bit better than its colder alternative. Overall, when it comes to clearing ice out, frozen water traps all kinds of gases. Remember those conspiracy theories about ancient world-ending plagues being released as a result of the polar caps melting in the South and North Poles? Yeah, ice holds a lot more than just ancient sick insects. It can trap pretty much anything, from minerals to air bubbles, and hot water really helps clear this out because it dissolves those gases and kills those impurities. Maybe it's less clearing the ice and more obliterating whatever's inside it. But either way, what you need gone gets gone pretty fast. Have you ever thought to question why people use tin foil when they're baking? It's because it really helps keep the crust from overbaking, or in the worst case scenario, even burning. Why does it do that though? Well, the foil acts as a barrier to the heat, so it doesn't let all of it get through. This means that not only do you get even cooking thanks to the edges of your pie being closer to the heat source, you also get to ensure it cooks more slowly and at a more even rate. Pies also tend to have their crusts shrink on them, especially when they're filled with fruits and liquid fillings. The aluminum filling helps to make sure those edges stay in shape and don't pull away as the dough starts to cook and expand. It's not just a decorative choice. There are actually loads of reasons to start using tin foil to make sure you get the pie you should be eating.